Section 6, and Chapter 2, Section 7 focuses on estimating decimals and approximating square roots. We are going to estimate products by rounding with decimals. First, we're going to round each decimal to the highest place value, unless you're told otherwise. If you're told to round to the second highest place value, you can go ahead and do that. But if it asks you to round, just go ahead and round to the highest place value. And secondly, we're going to multiply the rounded factors. So first, we're going to round to the highest place value, and then second, we're going to multiply the rounded factors. Now, estimating is a good way to check where you know that decimal point should be. So if we estimate, we can actually go back and double check and say, okay, yeah, this is where the decimal point should be in this. So it's a good way to check. So if we have 5.21 times 72.8, and we're asked to estimate, the highest place values are going to be the 5 and the 7. So we would round that 5.21 to 5, and then we'd round the 72.8 to 70, because 2 is not greater than 5, so we would round down, so that would be a 70, and then we multiply. 7 times 5 is 35, and then we add the 0. Now that little wavy equal sign actually means approximately to, or approximate. It's referring to our estimation, what it should be close to. So 350 is the estimation, while the actual number, 379.288, is the actual answer for those two numbers. But the approximated number is 350. So if I forget how to add in those decimals, I know that I should have a total of 3 decimal places, but let's say I forget that and I multiply 5.21 times 72.8 and I get 379,288. I'm like, oh no, I got to put in the decimals. Well, if I approximate 5 times 70 and I identify that it's 350, I know that my decimal place should be around 350. So I know exactly where to put in that decimal place. So if I have 8 times 6.742, here's my multiplication. Well, I don't know where to put my decimal place, right? Okay, but if I go ahead and add these, or I look at 6.742, I know I should have 3 places to put in my decimal. I can go ahead and place it 53.936. Yeah, that's fine. But if I just estimate, this can also help me. So if I estimate the 8 and the 6, I round to the highest place. 8, okay, stays the same. 6.7 rounds up to 7. 8 times 7 is 56. So that shows me that my decimal place should be between the 3 and 9. The decimal place should be around that 53 because I'm estimating that the whole number is around 53, 56. Okay, so I plug in my decimal place between the 3 and the 9. So I can use 2 ways to plug in the decimal place, or help me plug in the decimal place. One by estimating, and one by just counting how many decimal places I have. I want you to go ahead and estimate the cost if you went to a bike store and you had to buy helmet, gloves, knee pads, and a patch kit. So go ahead and estimate each one of these items and then estimate the total cost. Okay, so the helmet should be $50. The gloves, we're rounding down to 20. The knee pads, we're rounding up to 20. Okay, because the 5 is 5 or greater. That rounds the 1 up to a 2. And then the patch kit rounds up to a 3. So now I have 50 plus 20 plus 20 plus 3 is $93. Now, if they ask me to round this to the second highest number, I would be looking at 49, okay, 0.95, so the 95 is greater than 5, so that would round up to 50. The 21.95 would round up, the 95 would round it up to a 22. The knee pads would round up to, or round down to a 15, and then the patch kit, $2.50. So I look at what is not estimated if I just added up the totals, 89.89, and then you can see a highest place estimation is 93, and then a more specific estimation, 90.5, is closer, but still not exact. Now remember, when estimating with division, compatible numbers can be used to make the problem simpler. Now remember that when we're estimating with division, compatible numbers can be used to make the problem simpler. With the same thing with multiplication, the placement of the decimal point in a quotient of division can be checked with estimation. So just like we said with multiplication, we can check the estimation. We can check what we did in the division by estimating. So if I go ahead and I look at this and I have to estimate, if I have to divide, I can kind of estimate in my head where this is going to kind of lie. So if I look at maybe the highest place value, 6,000, okay, the 2 rounds down, so it says maybe 6,000, while the 0.9 could round that up to a 1, and that would give me 6,000. So I know where I'm going to put my decimal point. It's going to be after all 3 of those zeros, right? Because 6,000 point, okay, keeps it 6,000. So if I go ahead and go back, and I'm just asked to divide, I can kind of estimate in my head knowing that my answer is 6,000. Okay, I want you to go ahead, try these practice problems. Go ahead, pause it now, see if you got the correct answers. I want you to go ahead and estimate to the highest place. Number 1, if we estimate to the highest place, that would give us a 3 and a 1, so 3 plus 1 is 4. Number 2, we round down to 10. 3 is below, so we're going to round that down to 10. Now if I go to the second highest place, the 8 would round it up to a 14, and then it would be 14 minus 4, which would be 10. But if we go to the highest place, it's going to be 10 minus 4 is 6. If we estimate with multiplication, 3, okay, 0.47. The 4 is below 5, so that's 3. For 2.5, it's 5 and above, so that would round to a 3. So 3 times 3 is 9. And then number 4, 1.342 times 10. So 1 times 10. 1.342 times 9.6. The 1 rounds down, and then the 9 rounds up to a 10. So 1 times 10 is 10. Okay, so now we're moving on to the next section, and that's dealing with square roots. So we're going to get into a little more about approximation and estimating. Now, we did talk about square roots, and remember we are dealing with square root of 4 is 2, square root of 9 is 3. But what if we have a square root that is not a perfect square? So we know that square root of 4 is a perfect square. That would give us 2. So 2 times 2 is 4. And the next one that would be a perfect square would be 9. So square root of 9 would be 3. So 2 times 2 is 4. Okay. 3 times 3 is 9. So what if we have a square root between the square root of 4 and the square root of 9? So maybe the square root of 5 that we can see at the bottom. That does not give us a perfect square. So we have to kind of approximate where that square root of 5 would be between. And we kind of already did that, in which we said that we have square root of 4 and we have square root of 9. So the square root of 5 would have to be between two perfect squares. So let's talk about that now. So number 1, If a whole number is not a perfect square, its square can only be approximated. Okay, we can only kind of guess where it's going to be. The approximate value of the square root of 3 is between 1 and 2. That is because we know the square root of 4 is 2. So the square root of 3 has to be between 1 and 2. So it probably has to be between the square root of 1, which is 1, and the square root of 4, which is 2. So we're going to determine the perfect squares that the numbers are between. Then we're going to go ahead and find the square root of those perfect squares and give a range of values. So we are focusing on a range, and a range just means smallest to highest. Okay, this is pretty easy if we think about it. Okay, let's talk about the square root of 5. We kind of already did that. We know 2 times 2 is 4, 3 times 2 is 9. So that 2 times 2 is 4, so the square root of 4 is 2, and the square root of 9 is 3. So the square root of 5 has to be between 2 and 3, which 2 is the answer of the square root of 4, and 3 is the answer of square root of 9. And if we look at that, 4 is less than 5, and 5 is less than 9. So if I add square roots to all of those, okay, square root of 4 is still less than square root of 5, and square root of 5 is still less than square root of 9. So really all we have to do when we're given a non-perfect square is just think about what are the square roots that are perfect squares closest to it. So if I say, how about the square root of 9? Well, what's the closest square root or perfect square root to the left of it, smallest or smaller than square root of 9? Okay, let's do maybe the square root of 10. Okay, the square root of 10 is not a perfect square. So I have to look to the left of it. What's a number that is a perfect square root below 10? Okay, we know it's 9. The square root of 9 is 3. Okay, so that would be on the left. So the square root of 9, okay, which is 3, would be less than the square root of 10. Now, what perfect square would be greater than 10? Okay, so we know if square root of 9 is 3 times 3, let's try 4 times 4. 4 times 4 is 16. So 16, the square root of 16, would be greater than the square root of 10, and that is 4. So 3 is going to be this square root of 9 is going to be less than the square root of 10, and then the square root of 10 will be less than the square root of 16, which is 4. So we can think about what numbers are squared. Okay, I used 3 times 3, 3 squared, to help me figure out what 9 was, and then I used 4 squared, which is that next number, to help me figure out what is greater than 10. And then I can go ahead and use other numbers like 5 squared, which is 25, 6 squared, which is 36, to kind of help me visualize this. So that's something you will have to do to kind of help you understand this, or if you have an assessment like that, okay? Now, when a number is written besides the square root symbol that has no sign, no parentheses, no multiplication, no division, we're going to assume multiplication is indicated. Now, here, when we estimate or approximate, remember that little symbol, that wavy line symbol, means approximately to or almost. So let's take a look at this. Okay, 5, the square root of 16. So I can go ahead and do the square root first. The square root of 16 is 4. So basically, because the 5 was right next to the square root, it's telling me that I'm multiplying the 5 times the square root of 16. And that number was 4. So 5 times 4 is 20. Okay, now let's estimate or approximate. for the square root of 65. Okay, here's the problem. 65 is not a perfect square. So let's figure out, just like we were doing with the range, let's figure out what was the closest square root. Okay, 2 times 2 is 4. No, it's not going to be square root of 4. 3 squared is 9, not the square root of 9. 4 squared is 16. Nope. 5 squared is 25. Nope. 6 squared is 36. Nope. 7 squared is 49. Okay, we're getting closer. 8 squared is 64. Okay, so 8 squared being 64 is the closest square root. So what we're going to do is we're going to approximate. Okay, remember we're doing 4 times the square root of 65. So if we're going to approximate, we can go ahead and do 4 times the square root of 64. And that would be 8, right? So let's go ahead. Okay, we're saying the square root of 65 is close to, or the closest perfect square is 8, okay, which was the square root of 64. So now I can go ahead and do 4 times 8 is 32. That is my approximated or closest number, because if I go ahead and do the square root of 65, I'm going to get some decimal, okay? So if I approximate, I need to figure out in my head what are the closest square roots. Okay, I'm going to go ahead and have you try questions 1, 2, and 3, and then you can go ahead and try 4, 5, and 6. Now, questions 1, 2, and 3, we want to kind of figure out the range, what two whole numbers is the square root between, okay? What two square roots it will be between, and then that will give me my two whole numbers. Then for question 4 through 6, I want to estimate, okay, the final answer, okay, because 4, 5, and 6 are not perfect squares. We're going to go ahead and estimate what would be the closest answer. Go ahead, pause this, and go ahead and try it. Okay, so let's go ahead and try this. The square root of 41. Now, I want to go ahead and think in my head, okay, 2 times 2 is 4. Okay, the square root of 4 is 2. Okay, so that's not even close to 41. 3 times 3 is 9. The square root of 9 is 3. Okay, 4 times 4 is 16. Okay, square root of 16 is 4. 5 times 5, 25. Square root of 25 is 5. Okay, I'm getting a little closer. 6 times 6 is 36. That's a lot closer. And 7 times 7 is 49. Okay, so here it is. Okay, 6 times 6 is 36. So the square root of 36 is going to be less than the square root of 41. And then, okay, 7 times 7 is 49. So the square root of 41 is less than 49. So if I ask you what are the two square roots that square root of 41 would sit between, it would be the square root of 36 and the square root of 49. Now, if I ask for the whole numbers, okay, we wouldn't keep square root of 36. We would go ahead and kind of figure out the answer to square root of 36, and that is 6. So 6 and 7 are between the square root of 41. Okay, in the same way, 5 times 5 is 25, and 6 times 6 is 36. Okay, 5 and 6 are going to be on either side of the square root of 29.7. So square root of 25 and square root of 36, okay, are on either side of the 29.7. And then 4 times 4 is 16, 5 times 5 is 25. So those would be those two numbers between the square root of 24.7. So I hope that makes a little more sense, and we can do some practice on Monday. Now let's estimate the square root to the nearest whole number. Okay, we know that the square root of 36 is 6. So we could maybe do that, or we can look at a smaller number. Is there a smaller number closer? it's going to be square root of 25, which would be 5. So to estimate to the nearest whole number would either be 5 or 6. Now 6 is too high, so it would actually have to be 5. So the square root of 25 is 5, but the square root of 6 is closer. So I want to go ahead and estimate to the nearest whole number. And so the closest one is going to be the square root of 36, which would be 6. And then the square root of 18, we are dealing with the square root of 16, which is 4. That's a close number. Okay, what about if we go up higher? Would be 5 times 5, 25. 25 is maybe a little too far away, so square root of 16, which would be 4, is closer, and that would give me 4. And then the square root of 119 is 11. So 11 is the closest.